Zoom upgrade ചെയ്തപ്പോഴേ ആകെ പ്രശ്നമായി. ഇപ്പോൾ audible അല്ലേ? Hello?
Clear answer.
So let us, this is the definition of transition probability, WI2F. So final state, initial state, scalar product, then expectation value, then modulus square is the probability density or transition probability. Probability density or transition probability between two states, different states. Now put P equal to 1, first order perturbation. So psi of t equal to, from that 15, put P equal to 1. So first we limited infinity to finite number of time intervals, then now time interval be put into 1. Okay, so this is the equation number 15. You put P equal to 1. So psi of t equal to n equal to 0 to 1 un t t0 psi of t0. Okay, now you put n starts from 0, so first you put n equal to 0, then plus some n equal to 1. So u0 t t0 psi of t0 plus u1 t t0 psi of t0. Okay, this is the expression. Then you put P equal to 1. Final wave function. Only you remember the Feynman diagram. Only one interval we are choosing, T1. Okay. So then now find the transition probability. Okay. So this one is, this is the final state. This is the final state. Now you multiply it with the initial state psi I. Take the scalar product. So you put it as a Catanbra notation. So psi of t you put this psi I. This is psi I of t0, psi I of t0, and take a scalar product with psi f. Take a scalar product with the final state. So here we put a psi I like that. So this becomes u0 t t0 psi I, u1 t t0 psi I. This is psi I. Put give subscript I for all these. Okay, so psi I equal to, you get this expression. Take the scalar product with the psi f on the left side. So psi f, all the side you put a psi f. Okay. Now this u0 t t0, that you can write it as from equation number 12, put n equal to 0, equation number 12. See, this is put n equal to 0 here, so you get h cross to the power of 0, integral t0 to t. No integrals are there, u0, t0, t0. So that is, this is 1, this is 1, so this is 1. Finally it is 1. Now put n equal to 1 in that expression. So you get IH cross to the power of minus 1. IH cross to the power of minus 1, only one integral, 0 to t dot t1, then dot t1, u0 t1, like that. Okay, so you get this expression, u0 t1, v of t1, u0 t1 t0. So you look at that equation, put n equal to 1 and terminate that expression like this. So you got u0, so you got u1, you have to substitute here and here. This is u0 and this is u1. Put the u0 here and put the u1 here. So psi of t equal to psi f of t, this is 1, then psi I of t0 plus psi f of t is taken at the left side, draw psi f of t, then the entire thing is written here, IH cross to the power of minus 1 integral t0 to t dot t1 up to this, then psi I of t0. Okay, this one, psi I of t0. Now you simplify this. Okay, from first you simplify this first term, psi f1 psi I. 1 you can simply remove 1. So psi f psi I will come. So psi f you can write it as, and it is actually the brass psi f, so you have to take the conjugate star. Okay, so this is the 17, equation number 17 is this one. So in this you put k equal to f, so you get uf ef, but take the star conjugate, so minus I becomes plus I. So substitute it here, this much is psi f. Now psi I is this much. Okay, now you simplify this one. So uf ui you can square product, you can put it on the left side. If that is normalized, or since if that is normalized, you can basis vectors, you can write it as delta fi. Okay, and now these two you can combine as e to the power of I by h cross ef minus ei into t minus t0. Okay, so this you can write it as delta fi, because when f and I are same, this is 0. Oh, sorry, it is 1. When fi and I are different, this is 0. Okay, so this you can write it as delta fi. Now when n equal to 0 means, that is the meaning of n equal to 0. That is this case, first case. This term n equal to 0 means f equal to I. Initial state and final state are same. So ef equal to ei, so this becomes 0. Okay, when n equal to 0, this becomes 0, so that is 1. E to the power of 0 is 1, so that this one is delta fi. You can write it as delta fi. Now take the second case, this term, second term. So the first term becomes delta fi. Now take the second term, psi f ih cross minus 1 integral t0 to t dot t1 u0 v u0 psi I of t0. Okay, so that you can simplify it as ih cross to the power minus 1, you can take it outside. Then integral t0 to t, this psi f of t, and this entire thing you can take it as an integral dot t1. Instead of psi f of t, you can write e to the power of I by h cross ef into t minus t0 into uf, which is the bra psi f. Then u0, then v of t1 u0, u instead of psi I, you can write ui into e to the power of minus I by h cross ei into t minus t0. Okay, so that is the simplification. Now this can be again written as dot t1. These two things you can combine, exponential you can combine. This thing, the uf ui expectation value you can take here as same. And these exponentials you can combine. Okay. So that it becomes EF minus EI into T minus T0. Okay. So these two powers you can add and it becomes I by H cross EF minus EI into T minus T0. Okay. So these two things we have to substitute here for these two terms. Now, in this psi f from 1.3 we already have this u0 and the u0. This is the expression for u0, and you change t to t1, t1 to t0, you get this expression. Okay. So in the time evolution operator, you can change the time instance as you like, t to t1, t1 to t0. So these are the u0 t t1 and u0 t1 t0, which are this one. This is u0 t t1, which is this one, and u0 t1 t0 is this one. Substitute these two here. Okay. So this thing becomes psi f of t ih cross to the power of minus 1. Left side is same, this one is same, equal to, so this one becomes ih cross to the power of minus 1, ih cross to the power of minus 1, integral t0 to t dot t1, then e to the power of this quantity, then uf, then u0 you have to substitute from this one, e to the power of minus I by h cross h0 into t minus t1, then v of t1, then u0 t1 t0 is this one. Substitute that one. Now you simplify that. So you get ef minus ei t minus t0, then e to the power of minus I by h cross. When h0 is acting on uf, you get ef. When h0 is acting on ui, you get ei. And that ui uf here. This comes and this comes after the action. Okay. So now this can be again simplified into this one, integral ih cross minus 1 integral t0 to t dot t1. You just check this algebra. Okay, so you will end up with this one, which you can finally write it as this thing you can write it as VFI, because this is our expectation value of perturbing potential between UF and UI. So that is, you can write it as VFI. See, represent that by VFI of T1, then e to the power of I by h cross EF minus EI. You can write it as h cross omega. H cross omega, and h cross, that one h cross cancels, so you get I omega Fi T1 minus T0. See, omega Fi, you can write it as EF by EF minus EI by h cross. Or difference in energy is h cross omega, which is the Bohr frequency. E delta E equal to h cross omega is, where omega is the Bohr frequency corresponding to the transition psi A to psi F. Okay, now substitute these things in this expression for this one. Here you substitute back all these things. You will get psi F into psi I, that is delta Fi, plus ih cross to the power of minus 1 t0 to t Vfi t1 and e to the power of I omega Fi t1 minus t0 into dot t1. Okay. Now for simplicity, you put initial time as 0 and final time as t prime. Also assume that I and f are always different. Initial state and final state are always different, not the same. So you can write psi of t into psi I of t equal to, so if I and f are always different, this is 0. This conical delta becomes 0. Plus, so that is equal to h cross to the power of minus 1, 0 to t, t 0 to t, v of I t dash. This becomes v of I t dash, t prime, e to the power of I omega of I t dash dot t dash. Okay. Now take the modulus square of this one, which is the transition probability. Okay. So you take the square of this one. So IH cross to the power of minus 2. That is I square means minus 1. So 1 by I square. 1 by I square means minus 1 and h cross square 1 by h cross square integral 0 to t v of I t dash e to the power of I omega of I t dash dot t dash modulus square is the transition probability, which is the very important formula. So this is the basic equation for the first order time dependent perturbation theory. In the perturbation theory, we found this final expression for finite state wave function, and from that we evaluated the transition probability. Okay, so this is 1 by IH cross whole square, and you have to take the modulus also. Modulus takes, when you take modulus, minus sign goes. So 1 by h cross square integral 0 to t v of I t dash e to the power of I omega of I t dash d dot t dash or modulus square. Okay. So this is the important equation. From this, now we can move on to two types of perturbation. One is a constant perturbation and a harmonic perturbation. Okay, two types of perturbation now we have to deal. Constant perturbation means it is not fully constant. Constant means it is like this. See, it is constant for a particular time, then it suddenly changes. Constant potential means like that. See, it remains same for some time and it suddenly changes. So this is a case of constant potential. Actually, in your syllabus, you have the scattering chapter. So in that scattering chapter also, you can assume like the potential like this. One approximation is like this. One method approximation is like this. So the incident particle comes very near to the target, and up to that point, potential is assumed to be 0. Then at that particular point, potential starts to act. Then the system evolves with that potential up to some point. Then after that point, scattering is over. Then again potential is assumed to be 0. So that is scattering problem. We can treat like a constant perturbation. Is that idea clear? This idea we will use in one of the approximation.